Hello, this is Ed Chapman, and this video cast is going to cover some of the other properties of water. Here's the complete list of the 5 different properties of water that you need to be familiar with, and we have already covered hydrogen bonds in a previous video cast. In this video cast, we're going to focus on these 3 properties of water, and we're going to save pH for a completely separate video cast of its own. All right. Water, you probably have been taught at some point in the past, is what they call a universal solvent. And all that means is that water will dissolve just about everything to some degree. Now, some materials dissolve very easily in water, like sugar and salt. And other materials don't dissolve very well at all, like most metals. But that doesn't mean there aren't trace amounts of metals dissolved in large bodies of water, for example, like ocean water. Now, you do need to understand that the human body is made up of about 70% water, and this water is very important to the functioning of our living cells and our tissues. The water contains so much water because, the body contains so much water because it's the solvent in which a lot of different solutes are dissolved. You probably have noticed that tears are salty and that blood has a salty taste to it, so that means sodium chloride is dissolved in body fluids. There are also things like potassium, different sugars, and different hormones that are dissolved in this solution that makes up what we call body water, which in this diagram is about 72% of your total body's mass. Okay, the human body uses this water for lots of different things, but most importantly, this water is used to wash away waste products. So your body literally uses water that you swallow by way of your kidneys to wash waste products out of your bloodstream and eliminate them from the body. And if this process were prevented from happening, let's say if your kidneys stopped working, you wouldn't live very long. You'd have about 3 days of life left if your kidneys completely stopped working. So they're critical to the health of your body. Okay, water also has something called high specific heat, which means that it takes a large amount of heat to make water evaporate, and on the other side of the situation, water will give up a large amount of heat before it freezes. So this means that large bodies of water can act like giant heaters or coolers and produce a climate moderation effect. So if you live in a place that is close to a large body of water, like say you live at the seaside near the ocean, during the day when the sun is up, the land is going to heat up very quickly, and the air above the land is going to warm and start to rise because warm air rises. The air over the ocean, which is cooler, is going to warm up more slowly. So as this air over the land rises, it's going to pull a breeze inward from the ocean towards land in the morning, okay, or during the day when the sun is shining. So if you're flying a kite on the beach, your kite's going to be, going somewhere like this, all right? Now, conversely, at night, when there's no sunlight heating up the air, the land is going to cool down much more quickly than the water is, and so the warm water is going to be radiating heat upward, so the air is going to be rising, so it's going to be pulling cool air off the land. And so if you were flying a kite at night on the beach, the kite would be out here. All right, you get the idea. So what this means is that areas near the beach or near large bodies of water are going to experience a much more pleasant or moderate climate than areas that are farther inland because of this heating and cooling effect of large bodies of water. So if we look at a map of the United States, let me get rid of that writing. If you look at a map of the United States, you can see, this shows you temperatures by color coding, that the warmer areas go higher farther north on the coast, and the cooler areas penetrate farther south in the interior of the country. So this blue area, which is as far away from the Pacific over here, we've got the Pacific Ocean over here, and the Atlantic Ocean over here, we've got some Great Lakes here, but the colder areas in the winter are going to be interior in the inside of the continent, whereas near the coasts, you're going to have the moderating effect of the Pacific and Atlantic Oceans, keeping the climate warmer in the winter and cooler in the summer along the coastlines. This is the primary reason why people like to live near oceans. It's just a nicer place to be. Because water has such a high specific heat, which means it can absorb a lot of calories before it actually turns into a gas, water is an excellent way to pull heat out of a hot body. And so this is why sweating works. When anybody sweats, what happens is body heat is leaving by being absorbed through the evaporation of water on the surface of your skin. This picture here shows a kangaroo. Control Z. Okay, this kangaroo is actually applying a layer of saliva to its forearms because kangaroos don't have sweat glands. So what happens is as the saliva evaporates, it cools blood in blood vessels right beneath the skin. So it's one of the ways that a kangaroo can take advantage of what we call evaporative cooling. And here we see a person evaporating, and as the sweat evaporates from your forehead and from your scalp and from your body, it's pulling heat out of your body and helping you stay cool, preventing overheating. Okay, water also is constantly evaporating from trees, from leaves. We have a word for this. It's called transpiration. Okay, we've gotten that before when we talked about the water cycle. So as water is evaporating from leaves, it's cooling the air in amongst the leaves, and so this cool air is falling. Okay, so if you stand beneath a large tree on a hot day, it's going to be shady under the tree, and it's going to be cooler here also. But because of the cool air falling down from between the branches, the tree is functioning as a natural air conditioner. So it's going to be a lot cooler in neighborhoods that are covered with trees than in neighborhoods that just have sidewalks and roads and buildings. So trees are a good thing in the urban landscape because they make streets more habitable and more pleasant, especially in the summer. Okay, so it all has to do with evaporative cooling. Okay, another property of water is the fact that ice floats. Now, this is kind of obvious. Everybody's seen ice floating in liquid water, but this is a weird effect in physics because most solid things are denser than the liquid form of that same material. Have you ever played around with wax in a candle? Solid wax will sink to the bottom of a pool of liquid wax, but water is just the opposite. When water freezes, the ice actually floats. So this means, for example, with this picture of an iceberg here, that frozen water floats in liquid water. And this means that when temperatures in the air get cold enough to cause water to freeze, it's going to freeze from the top down. So as these, for example, on this pond, as ice crystals start to form and cover the surface of this pond with a layer of ice, the ice is going to stay up near the top, and eventually it's going to completely freeze over, leaving liquid water below. And this is incredibly important for life because this means living things that are in the water can survive through the winter without being frozen solid. If, in fact, the ice crystals sank, like most substances do when they turn into solids, you would actually get an underwater snow effect where ice crystals would slowly trickle down to the bottom, accumulate on the bottom of the pond or the ocean, and freeze from the bottom upwards. And, of course, this doesn't happen because liquid water is more dense than solid water or ice, and so ice floats. Okay, we'll stop there, and the next video cast will be on pH.